Alright, so today we will study about the topic of gravitational potential. Okay, what do you mean by gravitational potential? See, the work done in bringing a unit mass from infinity to a point in the gravitational field is called as your gravitational potential at that point. Clear? For example, see, try to understand. So, for example, this is your body having mass capital M, and this is a small body having mass small m, right? So if we are bringing this body from some infinity point to here, for example at this point we are bringing this body from infinity to this point, alright. So obviously this body will have some gravitational field. Okay, so the work done in bringing this body from infinity to this point, right, that amount of work done is the gravitational potential at this point. Means this point is your reference point. If we are bringing this body at this point, okay, then the gravitational potential will be different. If we are bringing this body from infinity to say this point, right here, then the gravitational potential will be different, because the amount of work done is different in all the cases, and that is depending on the position of the object. Clear? Position of the mass. Okay, so gravitational potential means this is the concept. Now see, gravitational potential is defined by or denoted by V generally. Alright, so V is given by W upon M. Okay, this is the formula for calculating gravitational potential, where W is your work done and M is your mass, which we are bringing from infinity to a reference point, and V is your gravitational potential. Alright, now one thing you have to note, that in this process this work is not the work done by the agent, it is the work which is obtained by the agent. Clear? So this work is your negative, so W is always negative, okay, because it is the work obtained by the agent, right? So if W is negative, then obviously mass has no plus or minus sign, therefore this gravitational potential V is always your negative. Okay, means your gravitational potential is always negative. I hope you have cleared with the concept of gravitational potential. Okay, alright, so now next is the relation between your gravitational field and gravitational potential. Okay, now see, gravitational potential is a field function, right? I already told you it is a field function. What does this mean? This implies that it depends on the position of the point where potential is desired. Okay, just now I have told you that, for example, this is your mass m and this is your small mass m, which we are bringing from infinity to some point. So the position of this mass m, or the amount of or the value of potential will depend upon the position of this small mass m. If it is here, then value will be different. If it is here, then value will be different. Alright, that is the thing which is written here. Gravitational potential is a field function. Clear? Now see, what is the relation? Relation, you will write it as vector capital E. This E is your gravitational field. In the last video I have already told you that gravitational field is denoted by capital E. So capital E, vector capital E, this is equal to your minus of gradient of V. Okay, where V is your what? Gravitational potential. Just now I have told you, right? Therefore, when I will expand this gradient, what do you mean by this gradient? This gradient in mathematical form, it means that minus of bracket minus this is your delta V upon delta x, right? Del V by del x I cap, right, plus del V by del y j cap plus del V upon del z, and this is your k cap. Okay, so minus gradient V means this thing. Clear? So this is the relation between your gravitational field and gravitational potential, where E is your gravitational field and V is your gravitational potential. I cap, j cap, k cap are the unit vectors along x, y and z direction. Clear? This I hope you already know. So this is your relation. This is the equation which you have to use while writing the relation between gravitational field and potential, right? And this del V by del x, del V by del x, del V by del y, del V by del z, these are your partial derivative of potential function. This is the partial derivative of potential V, and when we are writing x, y and z, it means this del V by del x is the partial derivative function, potential function with respect to x. Del V by del y means with respect to y, and del V by del z means with respect to z. Clear? So this is the equation which gives the relation between these two terms, gravitational field and gravitational potential. Now this is the last thing. See, I have told you that the relation between gravitational field and gravitational potential is given by this equation. Alright, this equation. Now this equation can also be written in some different ways while solving your numericals, just to save the time. Okay. See, first time you can write E equal to minus dV by dx. Alright, where you will write this equation if your gravitational field is along x direction only. If the gravitational field which is given is only in x direction, then you can write this equation as E equal to minus dV by dx. Clear? You don't have to mention this y and z. Or if the given field is in along the y direction only, then E equal to minus dV by dy. Clear? Or if it is in z direction only, then E equal to minus dV by dz. Clear? So you don't have to solve the whole equation if it is along one direction only. Second thing, from this equation only, you can also write dV equal to E dot dr, minus of E dot dr. Clear? From this here, you can write this in this way also, where dr, this dr is equal to your dx I cap plus dy j cap plus dz k cap. Clear? And this E is your ex I cap plus ey j cap plus ez k cap, where x, y and z, they are your subscript. Here also they are subscript, and this I, j and k are your unit vectors along x direction, y direction and k direction. And ex, ey, ez are the gravitational field along x direction, y direction and z direction. Similarly, dx, dy, dz are along your x, y and z direction. Right? So basically these are your specific terms along the x, y and z direction. So in these two ways you can also write the equation while solving your numerical problems. Clear? Now I hope this concept is clear and the relation is clear. This will be helpful while solving your problems. So now still if you want to want something more related to this topic, then you can comment in the section below. And if you like the video, then press the like button. And yes, one more thing, some of you might think that the sir is teaching a very simple topic. See, The point is that this topic seems to be very easy. I can understand, but the thing is, in physics you have to understand the topic, you have to understand the concept first. Concept is very important. You don't have to memorize the concept or memorize the formulas if you understand the concept. So rather than memorizing, focus on understanding the concepts. That's why I'm teaching these topics. Okay, thank you.